Good morning. Let's talk about zeros of functions. The zeros of a function definition here are the x values that make the function zero. Now the function is represented by the y, or they might write it as f of x. What else is it? Doesn't this sound familiar? What else is it that makes the y value equal 0? What do we get when we substitute 0 for y? If you substitute 0 for the y, so we get the zeros. What's the other thing? X-intercepts, right? The only difference between the zeros and the x-intercepts is in the presentation. If we've got a function like this, here are our x-intercepts. 1, 2, 3, 4 of them. Let's call this -6, 0, and -2, 0, and maybe 1, 0, and 8, 0. We'll just label these points. Okay, now the zeros of this function would be given as just a list of the x values that you could put in that would make the function equal 0. So if you plug in -6, you're going to get 0. We know because the function has the point -6, 0. Likewise, if you plug in -2 for x, you're going to get 0 for y, and so on. The x-intercepts are generally going to be listed as the full point. So the x-intercepts would be -6, 0, -2, 0, 1, 0, and 8, 0. The only difference is in how you write the answer down. Now let's suppose we had a function, but not the graph. So let's say let f of x equal 3x minus 6. To find the zeros, we're going to replace f of x with 0. So it doesn't matter whether we put the 0 over here or we say let f of x, which is this, equal 0. Most people prefer to, they feel more comfortable with the 0 on the right side. So if we have this, all we have to do to solve this for x is add 6 to both sides, divide by 3. We get x equals 2. Therefore, the 0, it only has 1 because this is a line, right? No exponents. So the 0 is just 2. We also automatically know from this the x-intercept would be the point 2, 0. So that's all you have to do to find zeros of a function. Of course, if they're higher degree than linear, then there may be a little more work involved, but that's the whole concept right there. That's it.